Okay, so as I said, this is for 4.4b. Determine the products of a number and 10 or 100 using properties of operations and place value understandings. So those of you that were already here have these glued into your journals, so this is going to be a review for you. Those of you that were not, hopefully by the time this is done, not only do my students that were here have a refresher, but so do you. So we looked at the two properties of multiplication. We have the anchor chart at the bottom of your notes, but we also have it in color up here in the classroom. I moved all the anchor charts to the side so that they don't interfere with anything we need to do up front. So the first property is your distributive property of multiplication, basically telling us that no matter what order the multiplication is put in, you're going to get the same product. Who remembers what a product is? Jackson.
The product is like your answer, your sum.
Very good. Your answer to a multiplication problem. It's not your sum, because your sum is your answer to an addition problem. But yes, your product is your answer to a multiplication problem. Again, any notes you are missing, please get those added while we have this discussion. We're right here. So do you need to be. Okay, so look at the distributive property of multiplication. They've taken this number and they have grouped it in many different ways. So the initial problem is 327 times 10. Then they have decomposed 327 and put it in parentheses, which is called a group. So you have 300 plus 20 plus 7 in that group times 10. Regardless of how that is grouped, it is still 327 times 10, so the answer is going to still be the same. If you look at the second set of groupings, they have taken it and they have said, okay, we're going to take 300 times 10, we're going to take 20 times 10, and we're going to take 7 times 10. So now they've decomposed the number even more, but they've taken each decomposed number and multiplied it by 10. So if you look at below that, that created a second step. So you've got 300 times 10 is equal to 3,000. 20 times 10 is equal to 200. And 7 times 10 is equal to 70. Add those up, you're still going to get 3,270 as your product. Thumbs up if you understand that. The same thing is going to occur when you multiply by 100. Okay? 10 has how many zeros? 1. So if you look at that number, you took 327 and added a 0 to the back end of it. Same thing is going to happen when you are multiplying by 100. How many zeros are in the number 100? 2. So when we take the number 327 times 100, if you look at the product, it creates 2 zeros at the back end, right? 2 zeros in 100, 2 zeros at the back end of this number. Again, that is what makes it nice when we're multiplying by 10 and 100. So again, in this distributive property of multiplication, it doesn't matter how they group it, you're still going to get the same product as if you did 327 times 100. Okay? Now, here's a new note for you. That doesn't change if the number in front of those 2 zeros changes. For example, if I have 15 times 200, I still have the basic property of those 10 and 100 products. Okay? There are 2 zeros at the back end of the number 200. So if I can figure out what 15 times 2 is, I can add 2 zeros to the back of that and get my answer without having to do an algorithm for multiplication. Does anybody off the top of their head know what 15 times 2 is? Jesse?
It is
30, right? So if I know that 15 times 2 is equal to 30, and I know that the property of multiplying by 10 or 100 means I bring these 2 zeros in, then I can bring those 2 zeros in, and I've got my product without an algorithm for multiplication. Exactly. Everybody understand that? We practiced this last week, and we're going to practice it some more this week, but I did want you to see it and have a note there so that you had something to refer back to. The next property is your commutative property of multiplication. It doesn't matter which way the factors are organized. If you're multiplying factors, your product's going to be the same. So in the first example, we have 327 times 10 equals 3,270. Then the second example flips those two numbers around. 10 times 327. We still just took 327 and added 0 at the back of it. Okay?
It's just the same numbers in different order.
So regardless of the order of your factors, your product's going to be the same. Same thing when we're multiplying by 100. 100 has 2 zeros at the back end, so we take 327 and we put 2 zeros on the back of it for our product. Whether we do it 327 times 100 or 100 times 327, it's still going to be the same. So if we were to take, here I did 15 times 200. If I was to do 14 times 30, if I know what 14 times 3 is, all I've got to do is add a 0 to the back end of it. Who knows what 14 times 3 is? Close? Isaac? No. Harley? No. No. You guys are just guessing now.
34?
No. Last one, Blaine?
42.
42. So 14 times 3 is 42. If I put a 0 at the back end, I get 420. So instead of the actual algorithm for multiplication, I just did 14 times 3 first and added that 0 on the back end. Okay? Next, on the bottom, I'm not going to spend a lot of time on it because it actually gives you word for word what we've just gone through with both examples. But the key things to remember are down at the bottom. So if you didn't get these blanks filled in, you might want to go ahead and fill them in. Everybody down there? First of all, it says the blank of any number. What are we looking for in this exercise today? Jackson?
We're looking for the product.
The product. So we are looking for the product of any number times what? 10. We can find that by placing a 0 at the end of a number. Each number shifts how many places? 1. What direction? And what takes the ones place? The 0 takes the ones place. So what that says, all in one is the product of any number times 10 can be found by placing a 0 at the place value position, at the end of the number. Each number then shifts one place value position to the left, and the 0 becomes the ones place. All right? So now we're switching gears to the second example we got. So we're still going to use the product, but now it is of any number times what? 100. This can be found by placing 2 zeros at the end of the number. Each number shifts how many? 2 place value positions to the left, and the blank the zeros become the tens and the ones place. Any questions on that? Now, if you were working virtually on the next part of your notes page, it basically told you to take the blue rectangle and move it to reveal the answers. Since we are not logged into a computer, we're going to go ahead and talk about those pattern and relationships that we see here. Again, a review for those of you that were here, brand new information for those of you that were not. Just yourself. You're next, Mr. Sanchez. Okay, so the pattern shows a pentagon times some number giving us a triangle. Look at the pattern of the relationships here between 24 and 240, 31 and 310, 57 and 570, 152 and 1,520. Jersey, what relationship do we see here? Times 10. Okay, so we would take the number provided in the pentagon times 10 to get the answer we need in the triangle. Okay? So when any number is multiplied by 10, the product is 10 times larger, meaning that each digit in the number shifts one place to the left, leaving a 0 in the ones place. So to reveal this rectangle, we would get a 10. If you don't have that filled in, please fill that in now. Based on what we are learning in this objective, we know that the next example should result in a pattern of what?
Times 100.
Multiplying by 100. So again, we have numbers provided in the circle, giving us a number, that times a number, giving us the product in the square. So 24 to 2400, 31 to 3100, 57 to 5700, and 152 to 15,200. As Blaine said, we are multiplying by 100. So the answers revealed in these rectangular boxes would be the circle times 100 is equal to the square. When any number is multiplied by 100, the product is 100 times larger. Each digit moves 2 places to the left, leaving zeros in the places of 10 and 1s. And of course, the last piece of your notes is the same anchor charts we have here in the classroom. These are what we filled in together. If I have the commutative property and I can multiply the factors in any order, the product is going to be the same. So 5 times 4 gives me 20. And 4 times 5 will also give me 20. The distributive property, meaning no matter how it's grouped, the product is going to be the same. So here we have 23 times 2 is equal to blank. Decompose that number to 20 plus 3 times 2. Gonna get the same answer. decompose it some more and say, okay, I'm going to do 20 times 2 and 3 times 2. What is 20 times 2? 40. And 3 times 2? 6, giving us 46. Now notice, this is a 20, not a 10. But it is the same concept. How many zeros are behind that 2? 1. So if I take 2 times 2, I get 4. Bring that 1 to the back end and I get 40. Okay? These other two properties are not necessarily properties of this particular unit, but these are properties you did learn about in 3rd and 4th grade. So we put them all together as multiplication properties. And that is basically the product of any number and 1 is that number. And the product of any number and 0 is always going to be 0. The associative property looks similar to the distributive property, only the groupings are a little bit different. We're not decomposing numbers. We're just regrouping them in different ways. So in the first one, they've grouped 3 times 4, which gives you what? 3 times 4 gives you what? 3 times 4 gives you what? 12. And then 12 times 2 gives you? 24. Thank you. Now, in the bottom example, they've regrouped them. So 4 times 2 is put together. What is 4 times 2? 8. And when we take 8 and we multiply it by 3, what do we get? 24. So again, they were grouped differently, but their product stays the same. Any questions?